Welcome back to our Data Science for Beginners series. Today, we're diving into Chapter 6, Supervised Learning Algorithms. Supervised learning is a fundamental part of machine learning where we train our models using labeled data. Today, we'll cover three key algorithms: linear regression, logistic regression, and decision trees, along with random forests. Let's get started. In this video, we'll explain how each algorithm works, provide some real-world examples, and show you how to implement them in Python. Let's begin with linear regression. Linear regression. Linear regression is a simple yet powerful algorithm used for predicting a continuous target variable based on one or more predictor variables. 1. Concept: linear regression models the relationship between a dependent variable and one or more independent variables by fitting a linear equation to observed data. Example: y equals mx plus b, where m is the slope and b is the intercept. 2. Implementation: let's implement linear regression using Python's scikit-learn library. Example: from sklearn.linear_model import linear regression. Model equals linear regression. Model.fit x_train y_train. Predictions equals model.predict x_test. Linear regression is great for understanding relationships between variables and making predictions when the target variable is continuous. Next, let's move on to logistic regression. Logistic regression is used for binary classification problems where the target variable is categorical, typically representing two classes. 1. Concept: logistic regression uses the logistic function to model the probability of a binary outcome. It predicts the probability that a given input belongs to a certain class. Example: p y equals 1 equals 1/1 plus e caret z, where z equals b0 plus b1 asterisk x1 plus bn asterisk xn. 2. Implementation: let's implement logistic regression using scikit-learn. Example: from sklearn.linear_model import logistic regression. Model equals logistic regression. Model.fit x_train y_train. Predictions equals model.predict x_test. Logistic regression is widely used in applications like spam detection, disease diagnosis, and customer churn prediction. Now, let's explore decision trees and random forests. Decision trees are versatile algorithms that can be used for both classification and regression tasks. They work by splitting the data into subsets based on the value of input features. 1. Concept: a decision tree splits the data into branches based on feature values, forming a tree-like structure. Each leaf node represents a class label for classification or a continuous value for regression. Example: from sklearn.tree import decision tree classifier. Model equals decision tree classifier. Model.fit x_train y_train. Predictions equals model.predict x_test. 2. Random forests, an ensemble method that builds multiple decision trees and merges their predictions to improve accuracy and reduce overfitting. Example: from sklearn.ensemble import random forest classifier. Model equals random forest classifier n_estimators equals 100. Model.fit x_train y_train. Predictions equals model.predict x_test. Decision trees are easy to interpret and visualize, making them a popular choice for many applications. Random forests, on the other hand, provide higher accuracy by combining multiple trees and are less prone to overfitting. To recap, we've covered linear regression, logistic regression, and decision trees along with random forests. Each of these algorithms has unique strengths and applications, and they form the backbone of many machine learning solutions. In the next video, we'll dive deeper into model evaluation and validation techniques to ensure our models perform well in real-world scenarios. Make sure to download the course materials and practice the exercises provided. If you have any questions or comments, leave them below. Don't forget to subscribe and hit the notification bell